Modern software development environments have had a great impact on the software development lifecycle process. So, we can use these environments as we're going through the whole development of software. Most programming languages are now presented within an integrated development environment or an IDE. And so the IDE actually lets the programmer perform a number of tasks within the shell of a single application program, rather than having to use a separate program to handle each task. So all these steps that we talked about in the life cycle process, we could actually do most of it within a single IDE. So let me give you just a couple of examples out there. So we have like Visual Studio, that can do stuff like in C or C++ or C Sharp or Visual Basic. We have Eclipse that can be used for Java or C++. JCreator is also one that's used for Java, but we have all these different types of IDEs out there to kind of help us with writing the code, compiling it, running it, testing it, debugging. So all that's given to us in a single program instead of having to do all these different steps with separate programs. And modern programming IDE provides us with several different tools and features to help us with designing our software. So it usually includes a program editor or a text editor, a file manager for all our different files for our source code. It would come with a compiler or maybe even an interpreter. We would have a debugger that's built in so we can actually test some stuff. We may have a linker and a loader and additional tools to help us with that. We may have prototype tools that can be shown to prospective users in the initial stages of the software development. Now, these prototypes don't have to have any functionality, but they can give users an idea of what the final software package will look like. Kind of like seeing a small scale mock-up of the proposed software is a way we can kind of think of this. And then we can even have things to help with managing the version of the software or even the documentation itself. So, there are packages that help us track the requirements from the initial specification through the design process to the final code, just to make sure that nothing gets lost along the way. The software development process that we've been talking about is what's also known as the waterfall model of software development. So, think of this as a series of waterfalls just moving down a river and through various plateaus. So in the software development process, these plateaus would be each of the steps: the feasibility study, problem specification, and so forth. And the way we think of this is that the process is very sequential in that we have to complete one step before we can move on to the next step. And then the previous steps would never be revisited. This was, it's a very useful software in some ways. It was originally developed to describe the manufacturing process, where we would have one step and then we move on to the next step, then we would move to the next step. But the thing is with software development is that it's a lot more fluid. And in fact, there is some wiggle room in the waterfall model, but the pure waterfall model of software development is seldom used in favor of a more flexible approach that is instead guided by the waterfall model. So around 2001, there was a new software development model known as the Agile software development was started to be used. Now, the term Agile in the dictionary is defined as marked by ready ability to move with quick, easy grace, having a quick, resourceful, and adaptable character. So, this suggests some flexibility, nimbleness, and the ability to adjust to changes. So, the whole point here is that we need to be ready to make changes. We need to be able to make quick changes as needed. So, the whole point here is that the problem specification is never really done. It's never a done deal. There are bound to be changes during the whole process, and we must be agile in the response to these changes. So we might be later on in the process and realize that we need to make some changes in the problem specification. So we just go back and make those changes and then make those updates as we go. So, we have to make a response to these changes, and the customers need to be involved with working with the development team throughout the process. When we were talking about the waterfall model, it just seemed like that they were involved in the problem specification, and then the customers go away, and then the developers do all the other steps, and then they bring the customers back at the end product. But with the agile development, it's more about having the customers involved in all steps of the process. So, it's the whole suite of methods and processes to help promote this flexible and ready response to meet a shifting and ever-changing target. Because you might make something in there and then you bring the customers back and show them this is what we've done, what do you think so far? They may like it, they may suggest some changes, so we can make those changes now instead of seeing that we need to make those changes later on at the end. So this is just a way of making sure that we make changes as we go and not just do the updating at the very end. Now, there is one aspect of agile software development that's starting to show up in some of the computer science classes, which is called pair programming. So the idea is that we would have two programmers. So in this case, we would have two students at a single workstation. So at any point in time, one student is writing the code, and then the other student is just actively observing. So the observer is just going to watch each line of code for possible errors, but is also thinking about the overall approach. So what problems may lie ahead, and possibly spotting some improvements that can be made. And then the roles would actually be switched frequently. Now, how and when, we're not going to worry about. The roles would be switched. So the other person would start writing the code, and then the other person would start observing. And the whole point here is that we're emphasizing on cooperation and not on competition. So pair programming, if it's done well, would actually produce better code more quickly than a single programmer. Now, of course, there is the added cost of having two people working together. So for any particular project, the relative costs and benefits of pair programming would need to be weighed.